recording and let it record a little so I have evidence for parent-teacher. Amazingly, yes. Now, the microphone can pick me up, and that's all that matters to me. So I should say, I should really thank Ethan and Anthony and Sam and Christina and a few others, but they're further away from me, so I'm not entirely sure all of them for, doing what they're supposed to be doing. So we have to talk about the fact that we have only dealt with tangent. And tangent only applies to the opposite and the adjacent. Now that means the triangle has this side, and a third side. The opposite and the adjacent are only legs. Now you guys, not being unintelligent people, recognize that there is indeed a third side to the triangle. The third side is the hypotenuse. Now the problem with the hypotenuse is it never moves, and yet people have trouble with it, even though it's the one that's always the same. If I take this B and I move it up here, now all of a sudden the opposites and the adjacents have changed places, but the hypotenuse hasn't. And for some strange reason, that issue causes problems for people. Now, because there is that third side, we must have other ratios that deal with that third side, and they are sine and cosine. Now, if there are a couple of you in here that had not done trig before, you all were comfortable with the tan button. The tan button and the shift tan button have your calculator working out this decimal. It's that ratio that this button is doing and then reversing. So of course you recognize that right beside tan, you see another two buttons that is going to use, again, a ratio. But if you've been following along, you will recognize that it must include the hypotenuse. So we will start with the sine ratio, which on your calculator is the sin button. The sine ratio compares the measurement of the opposite over the measurement of the hypotenuse. Now, other than that, it follows the exact same rules. Sine gives you the decimal. Shift sine gives you the angle. Now, I need to remind you guys of this symbol because I can't remember which group I showed it to. I showed you that. That is theta. We are going to be using that all over the place today. The cosine ratio, again, you guys are intelligent young people, and even if you hadn't seen it, you would already be aware that it would be the cos button. And again, cos would get the decimal, and shift cos would get the angle. Now, which angles are we talking about? Well, obviously, if the three sides are opposite, adjacent, and hypotenuse, and I have covered opposite adjacent and opposite hypotenuse, what's the only thing left? Adjacent and hypotenuse. Now I need to remind you of the fact that adjacent means beside, but not the hypotenuse, because the hypotenuse is beside both other angles, isn't it? Now, This sets up this little pretend fake word that if you did trig last year, your teacher used. If you didn't, you're going to hear for the first time now. My fun little story about that little word is in 1989 when I was learning trig and my math teacher, Mr. Stewart, told us that word. I said, that word sounds Japanese. And Mr. Stewart said, what do you mean? And I said, Sokatoa! Because I thought it sounded like karate. Of course, now I actually know stuff about karate, and very little is there hiya in it. It's not Miss Piggy. It's real. And of course, it's 2016 where you're not allowed to make jokes like that. And Mr. Stewart was not happy with me, but that's okay, because I wasn't happy with Mr. Stewart, because some of you might be aware that Mr. Stewart and I had a disagreement over the fact that my girlfriend was in love with him. Mr. Stewart, I don't think, knew that Tamara was in love with him, but I did, and it was frustrating for me to leave Mr. Stewart's class and have Tamara always caring about how Mr. Stewart was, not how I was. She never asked about Mr. Aktemachuk, my socials teacher. She never asked about Miss Fowler, my English teacher. She never asked about Mr. Samuel, my phys ed teacher. She never asked about Mr. Hyde, my drama teacher. She never asked about Mademoiselle Morel, my French teacher, but I think she didn't ask about my French teacher because my French teacher was smoking hot and I had a crush on her. And I think that bothered Tamara a little because we were actually in the same class, and I think Tamara was aware that I had a thing for Miss Morel. And I think that covers all my classes.
In high school?
Yes. Oh, I was in love with my French teacher. She was gorgeous. She was like 22. Fresh out of university, and I was 16. So, it didn't seem weird. I mean, if I was 26 and she was 32, no problem at all. So anyway, Tamara cared a lot about Mr. Stewart, and it got on my nerves. Even though Mr. Stewart was a great guy, I liked him very much, but, much like you guys have a stunningly handsome math teacher in grade 10, I, too, had a stunningly handsome math teacher in grade 10. I recognize he was a good-looking dude, but you needn't talk to me about it when you were dating me, Tamara. But, it's okay. I saw Tamara recently. We were at a funeral together. Not for one of us because we were there. We both arrived at the funeral, and I wasn't expecting her to be there necessarily. But since we both knew the guy that died, the chances that she would be there would have been good. And she indeed was there. We did not talk about her crush on Mr. Stewart. Anyways. Long story short, this memory tool is sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. Tan, opposite, adjacent. Now, in this all kinds of blank white space here, I want you all to draw a triangle. Does it matter what it looks like? Not even a little bit, because the rules apply to everything. Most of you being honors type students are going to draw exactly the triangle I draw here, and that's okay. Some of you have already drawn a triangle. I am betting a great many of you have drawn a boring right angle triangle like that. Not on my watch, no. I'm drawing it like this. Woo, doggy! That is badass, but that's okay because it's still a triangle. So it follows all the rules. Now, I'm going to go ahead and name my triangle, and the funniest part of doing that is how many people just erased their regular triangle and drew mine. I know some of you did that. I won't point out who you are, but it's fun for me. I am going to name the sides A, B, and C. It doesn't matter how you name yours because the rules still apply. Now I am going to ask you to name the sides properly, the way we are going to name it in math class. So what is this side's name? Lil B. What is this side's name? Lil A. And what's this side's name? Lil C. Good. I told you the story about Lil. We're going to move on from there. I wish for you to tell me the sine of B, the cos of B, and the tan of B. Then I wish for you to tell me the sine of A, the cos of A, and the tan of A. Notice there are no numbers here because it is not a number that matters. It is a concept. Because no matter what is in the spot, that's what you put in the fraction. So what is the sine of B? Here is B, and I'm going to highlight him in red because I used red to write it out. Sine is opposite and hypotenuse. So I look opposite, I look hypotenuse, and I put B over C. Cos is adjacent over hypotenuse. So I say to myself, I go to where I care, which is the angle I care about, which is B, and I look and I see adjacent, but not hypotenuse, is little a, and hypotenuse, which never changes, is little c. And then you already know tan because it is B over A. Now, I wish to deal with angle A. So, am I in a different spot on the triangle? Yes. What is the two sides that change? Opposite and adjacent. Hypotenuse never changes. So now, it is still O over H, but I am going O, and H never changes. So the sine of A becomes A over C. Notice what has happened. The cos of one of the acute angles is the same as the sine of the other acute angle. Cos of A is B over C, and tan of A is A over B. Now, many people don't make the link between theoretical trigonometry, which is made up of letters, and real trigonometry, which is made up of numbers. But it is the same thing. So here is what we do to do trig. If you are bad at it, I cannot stress this enough. You can't be bad at it if you write it down. Because all you got, you don't even have to remember SOHCAHTOA, because if you look on your data booklet, you will see that it is provided for you. You don't even have to remember it. So we are going to look at this, and again, this is all you have to do to succeed in trig. 1, you need a triangle. Do I have a triangle? I do. 2, you need to know what ratio you're going to use. How do you decide? Well, do I have a theta? Do I have an angle that I know? What is it? 12. Now you know that this is 78, but that would require you to do some math, wouldn't it? Why wouldn't you use the one that's already given to you? You don't have to whisper. I can answer the question. Are you good? Okay. So theta is the angle that I know. What else do I know in this triangle? I have a hypotenuse of 25, and I need an opposite that is unknown. So now all I need to do trigonometry is choose the one of the three that uses O and H. And what is it? Sine of 12 equals O, which is X, over H, which is 25. Now, a great many of you will say, yeah, Myers, that's easy, but now I can't remember what to do. Again, first thing is we do it the long way. How would I get X by itself? Well, I would multiply by 25, and that would cancel. Now x is alone, yes? And if I do something to this side, I have to do it to this side. So x must equal 25 times sine 12. How do I get that on my calculator? It depends on my machine. It is either 25 times sine 12 equals, or, and here's where the problem happens, if you have a backwards calculator, you're going to push 25 times 12 sine, and then your calculator is going to go weird. It's going to show a giant bunch of numbers. And you're going to think you have the right answer. But you don't, because you haven't pushed what button? Equals. So now everybody do that and tell me what you get. So x equals what? 5 exactly?
No.
5.1, which I'm perfectly happy with. Now let's just prove it. I got my calculator out. 25 sine 12, close brackets, equals 5.19. I would say that's 5.2. Everybody got it? Now, if you have a backwards calculator, make sure you punch in the right order. You got to put the angle first. So, this next one, I'm going to change colors. Do I have a theta?
Yes.
What is it?
19.
19. Of course, I know the other one, but again, I don't want to do work that I don't need to do. 40 is adjacent, and h is my unknown. What uses a and h? Cosine. So cosine of 19 equals 40 over x. Once again, for math purposes, we are going to do the long algebra way, and then we'll talk about the shortcut. I need x by itself. It's not allowed to be down there, so I multiply both sides by x. Cancel, cancel. Now I have x times cos 19 equals 40. I still need to get x by itself. Woo, doggy. So I divide both sides by cos 19. Now, the answer will be 40 divided by cos 19, but that's not the point here. The point is I want to recognize the shortcut, which is when the letter's on the bottom, you divide. When the letter's on the top, you multiply. That's it. So now you can save yourself some time. Now when I go to my calculator, 40 divided by cos 19, close brackets, equals. And I get 42.3. 42.3. Now the next thing I need to do is check something. I was looking for the hypotenuse, wasn't I? So that number that I get had better be bigger than the number that I have, right? Because the hypotenuse has to be the longest side. If I had a nickel for every kid, including pre-diploma 10 kids, who punched that in wrong and told me that x was shorter than 40, I could quit this job. Because then I say, how can x be shorter than 40? It's the hypotenuse. And they say, and I quote, the calculator said so. If you really want me to go ape, blame your calculator for not knowing how to do math. Okay? Don't believe it. Find out in your head, using your brain to do a bit of math, which is where math is done in your brain, so you know where you're going, so you don't make those errors. Okay? Okay. This one, and I will change color a third time. Do I have a theta?
No.
No, I do not. But that's the angle I'm concerned with. I have an adjacent of 13 and I have an hypotenuse of 22. What uses A and H? Cos of x equals 13 over 22. I have everything I need. So I must be looking at a shift cos situation here because I need an angle. Shift cos of 13 divided by 22 brackets. Now, that's what you're going to punch in unless you have a backwards calculator, in which case you are going to reverse it, and you are going to go bracket 13 divided by 22, close brackets, shift cos. And you may or may not need to hit equals. It depends on your machine. So everybody should have done that, and you will get shift cos 13 divided by 22, close brackets, equals 54 degrees, because we don't measure degrees in decimals. So x equaled 54 degrees. Is everybody good? Now, please, please, please understand. Orientation of the triangle doesn't mean a thing. No matter how we draw it, we always use opposite, adjacent, and hypotenuse. So it doesn't matter. What does matter when you are trying to do trig questions is that you have a triangle. Understand? I have done so much trig that I don't draw triangles anymore when I am doing my own work. You guys haven't. So what should you do with every single trig question? Draw a triangle. Is this art class? No. All you got to do is draw a triangle. Doesn't have to be pretty. Okay? Draw it, write it out. You cannot do it wrong. Okay? Now, I assigned 2 pages of work that only was the tangent ratio because I personally find the tangent ratio to be a double-edged sword. I like you starting with tangent because those are the sides of the triangle that you guys like working with from Pythagoras, right? You're used to finding the hypotenuse. When I turn it around and I give you the hypotenuse, some of you still forget that it's subtraction and you give me the wrong answer. So that's why I like starting with tan, because it's the sides that you're used to. I like making you do 1,000,000 of them because that gets you used to the format of theta, side, side, and making the decimal. Was anybody unable to do any of that and get the... Were any of you, back to calm voice, unable to get the answers from the back of the book for 75 and 82? There is one brutally difficult question in there that was about the height of the sun and the solar panel on the house roof. That is a very difficult question. Otherwise, if you drew the triangles, it shouldn't have been too hard. Was everybody okay with it, or do I need to go over any part of it? Now is the time to ask. If you feel that maybe everybody is okay, but you might not be, then you need to see me because it is going to be very difficult to go further ahead if you are uncomfortable with the basics of trig on a right angle triangle, because you are all aware there are other kinds of triangles. But trig can be used on every kind of triangle. We just start with 90 degrees. Are we all good? Yes. The sun in the house one. Okay. Anything else? The sun in the house one is on the 82, is it not? It is on 75? Oh yeah. Okay.
Yeah, we get this one. The question and answers we got were like off by no. Yeah, that's fine. I figured out the sun one pretty
Like just run?
So that's the question, yes?
Yeah.
Right? Right? Okay. Sun's rays have to hit the panel. Yeah? So I care about the angle at which the sun's ray is hitting there, correct?
Yeah.
So that makes this triangle, doesn't it? Now, isn't that triangle going to be the same as this triangle, but reversed?
Yeah.
Right? So, which of these two angles, I'm going to call this angle A and I'm going to call this angle B, which one of them deals with where the sun is? B, because it's an angle of elevation, yes? So I got to check what B is. And if I find B, one moment, go for Myers. I do indeed. Okay. Bye. So all you're doing is tangent to find this angle, right? And if that angle is within for these cities, then it's going to work. Because those cities are, here's the Earth, there's latitude, those cities live up here, yeah? And that's where the sun is hitting. Okay, now the point of this is not to test if you understand what latitude and longitude is. You understand the rays of the sun hitting. That's not the point. The point is the complete opposite. That basic trig has so many different applications that all you're doing is this grade 10 calculation. That's the point. Okay? It was not designed to make you feel foolish. The question is designed for you to look at and say, latitude, sun, what? Huh? Crazy. I don't know. I don't get what latitude is. Oh, but wait, I do understand angles hitting something. Okay? I do understand that the sun is in the sky, so it must be an angle of elevation or inclination. Okay? Everybody with me? That's it. Any other problems with 75 and 82? We are all good? Sweet. That makes my life lovely. So we are at this point, solving the triangle. I'm going to come back to that in a moment. No, that is exactly where I wish to be. What's on your outline? You guys don't have those sheets. Curses. Okay, so I am going to go through this, and then I am going to set you guys free with your textbook today. Oh, and by the way, that I would like to commend you all Because it was the second time I had a TOC in here and the second time that nobody had anything bad to say about anybody. Wait, the sub had nothing bad to say about any of you guys. That's what I meant to say. What? Yes. Well, nothing, because it's just tests. I got to wait till the tests come back. But so far, nobody knows what's wrong with me. But this guy has wisely said, do you have any symptoms? No. Are you worried about this? No. Should I worry for you? No. Okay. So that's where we are right now. I don't care. And as you guys should be well aware after living with me for a month, I don't seem to have low energy. So, we'll see. I have one more specialist appointment coming up. This one is scheduled for early November. So in early November, I will be missing another day. Unless there is a cancellation. Now, this guy got to go all the way to White Rocker for some crap like that. So, I don't know. Pardon me? Well, the specialist isn't going to come to me, Beryl. Yes. No. Anyway, I have to go there. Now, obviously, I cannot get a school bus and bring you all with me to teach the class whilst I am seeing the hematologist. Do yourselves a favor and download, legally of course, the movie Summer School. If you haven't seen it yet, you should, because that's the reason I'm a teacher. That guy. Of course, legally. That's the only way you procure anything on the internet. By legally purchasing the right to view it. Of course, because the people that made it deserve to be paid because they put the effort in. Now is where we talk about this. Why do they get to be paid over and over again? Nobody is paying me for teaching you 50 years from now. If you use any math that I showed you by the music industry and the entertainment industry's logic, you should have to pay me for using anything I teach you for the rest of your life, which is idiotic because I'm being paid to do it now. But for some strange reason, if I were an actor, I feel that every time somebody views my work, I should be paid again. Whatever. I don't make the rules. Mind you, I think that would be pretty wicked if there was some sort of microchip implanted in you people, and every time you said or did something that I said or did, I got paid a penny. That'd be wicked awesome. Scarlett? That is true. People in film do not get paid a pension, but they are also paid $20 million to make a movie. All right? My daughter worked for one day and was paid the equivalent of my monthly salary. But the argument here also, Scarlett, is that is a choice that said entertainers made. Right? If all that mattered was a pension, then there's plenty of room for teachers in the world. Yet there's only 40,000 in all of British Columbia. That is a lot, except when you realize there's 3.5 million people that live in British Columbia. So it's not that much, right? Now, I'm not saying you don't deserve to be paid. Don't get me wrong. Everybody deserves to be paid. Blah, 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 blah. The point is, does James Hetfield for Metallica deserve to still get paid for the album he made in 1980? Yes, Michael Jackson. Well, no, Michael Jackson is not making money. Michael Jackson's estate is making money.
The song Happy Birthday is copyrighted.
Happy Birthday is copyrighted, but it recently came out of copyright. But I think it may be back in copyright. I'm not entirely sure. That is why when you watch TV shows, if they are poor TV shows, they don't sing happy birthday. They sing for he's a jolly good fellow, because they didn't want to pay the happy birthday licensing fee, which is super expensive. If you wish to have happy birthday in your movie, you have to pay a buttload of money. Anyways, let's get back to here. Solving a triangle. Same thing with everything else. When we solve a triangle, that means all the angles and all the sides must be known. Now, guys, this is a real bear to teach if the students don't understand what is going on here. How many choices do you have to use trigonometry? 3. You can do sine, cos, or tan, yes? How many choices do you have to find the length of a side? 4. Sine, cos, tan, and Pythagoras, yes? Is there any rule involving the order in which you do something? Is there? No. So I have a way that I would approach this problem. It might not be the way you would approach this problem. So bear in mind, you could do this any way you see fit. But I stress, if you write it out, you will know what to do. So here's what I like to do. I see I have a theta of 65, and I start working from there. Okay? The only thing I have from 65 is an opposite of 41. Yes? My adjacent is unknown, so I give it an x. My hypotenuse is unknown, so I give it an x. Not an x. I can't give it an x. Why can't I give it an x? Because I need a different variable. And my third angle, and there's another Greek letter for that, but I'm not going to tell you what it is. I don't want to mess with your heads. My third angle is simply 90 minus 65. Right? Because it's 180 degrees in a triangle. Everybody cool? So that's already out of the way. Now, I am going to use 65. Even though I know 25 is there, I am going to use 65. Do you have to use 65? No, you could use 25. It wouldn't matter. I don't care. Okay? I'm going to use 65 and 41 because that's what was given to me. Okay? So the first thing I'm going to do is I'm going to say sine of 65 is opposite 41 over this guy. Actually, I'm not going to use x. I'm sorry, that was a stupid thing to do. I'm going to use little c and little b because that's how we would name it properly, yes? Sine of 65 is 41 over little b. Agreed? Now, right away, that bothers some of you because I've made the hypotenuse b. Does it matter? Does it? No. So I now am going to do my math here. The variable is on the bottom, so this is division, yes? B equals 41 over sine 65. That's going to get me an answer. I'm not going to write it in because I don't want to get my calculator out right now. I'm just going to stop there because for me, the important thing as the math teacher is I also need tan of 65 to be opposite 41 over little c. And then again, that's a dividing thing. That will then give me everything. Could I have stopped here and gone to Pythagoras? Could I have done that? Yeah, because I would have had the hypotenuse on another side, right? Is either way better or worse? No, you just have to do it. Okay? Everybody with me? It doesn't matter which order. It doesn't matter whether you use sine or cos or tan. Doesn't even matter which angle you use. You just got to do enough to get all the answers. Okay? Do not think, like some kids think, that if you do it differently or in a different order from me, you're doing it wrong, because you're not. All right? I am in the business of you people understanding the concept and using said concepts to find the right answer. I don't care how you get there. All right? Meet me at Hanson at 5 o'clock. I don't care if you get there by rickshaw, as long as you meet me there at 5 o'clock. Understand? How many of you actually know what a rickshaw is? Oh, good. Usually when I say that, people are like, well, huh? So everyone can do this, yes? Now, obviously, you guys will have had your calculator in business. 41, turn on. 41 divided by sine 65. 45. 5.23. Does that make sense? It's the hypotenuse and it's longer than 41. Are we happy? Okay. And then the last one. Now, the last one should be the shortest side, shouldn't it? Right? So that is 41 divided by tan 65. And I get 19. Do I have everything filled in? Angle, 25, side. Good. Here is the next problem. Can you trust the triangle? Should you trust the triangle? Should you? This triangle shows that to be the shortest side across from the shortest angle. Is everyone okay with that? That's fine, but don't trust it if the math you do doesn't work out. Do you understand what I'm saying? What's the first thing I said to do with the trig question? Draw a triangle, right? So let's say you draw this. Well, that should mean that this side, x, is longer than y, yes? But what if it isn't? If you've done your trig right, don't trust your triangle. Do you understand what I'm saying? It's not a scale drawing. You didn't draw that to represent anything in real life. You drew that to help you do trig. Okay? Is everybody with me on that? Because I get that a lot from students. They'll look at a triangle drawn on the page and they'll be like, well, it's drawn that way. It has to be. No. Trig wins. Okay? The triangle's there to help you. Got it? Everybody okay? All right. So what I would like for you guys to do is do some work here. 95 and 101 out of your textbook. And now you have the whole battery of trig ratios available to you. Up until now, you were only supposed to use tan, which is a pain if you have to find a hypotenuse, yeah? Because you got to do tan and then you got to do Pythagoras. Now you don't have to do that. You can use sine and cos. All right? Everybody cool? Okay, now you will notice I'm going fairly quickly because we're already technically down to here, solving right triangles, yes? Because that is the bare beginning of trigonometry. Notice how much more of trig there is. Okay? Because this part is the easy part. Because we get to follow SOHCAHTOA. And it just works. Okay? Tomorrow, we will get into some word problems. All right? Now this right here, these are puzzle sheets. I like them. I have a lot of fun with them. but most kids really don't like them. You will also notice in my outline here, I have quiz after L6. L6. We are going to quiz after we've done our word problems. Now, if you look in your notes I've given you, you will notice that after we talked about angle of inclination and angle of depression, there's like 6 word problems, yeah? Next page. Oh, going forward, not backward, Christina. 1, 2, turn, 3, 4, 5, 6, 7. There's a bunch of work there, okay? So what I'm doing is I'm not going to do these puzzle sheets with you guys because in the regular class, trig ends here. Okay? So they are getting a ton of extra practice. You guys, tomorrow we're going to do these. Okay? If you feel ready, you're welcome to, I don't care if you go ahead, whatever. But these, of course, have the answer in the back of the book, so you can check yourself, yeah? The notes that you have a bunch of blank word problems. We're going to work through a couple of them tomorrow in class, and then I'm going to give you those to attempt tomorrow after you're comfortable with trig, okay? Because there's no answers there. So you're going to have to try it and trust yourself, all right? Everybody good? Then we'll quiz sometime after Tuesday. All right? Not going to be Wednesday. It'll be more likely Thursday or Friday. I like quizzes on Thursdays because it's a short day and you can't run out of time. Which segues me right into X block. I don't imagine any of you need an X block this week. With me in math class being in other pre-dip classes, most of you had done some trig in grade 9. You probably don't need me this X block. But if you do, put your name in this box, and I'll sign you up for it, okay? Everybody cool? Now, there is a bunch more trig that can get a little complicated, but it's all based on SOHCAHTOA. You'll be okay. But we'll have another X block in 2 weeks, and if you want to see me about that stuff, then that'd be cool. All right? Everybody good? Everybody understands what they're doing right now? You're going to be working on this stuff for now. Okay? I want you very comfortable with sine, cosine, tan, and right angle triangles. So comfortable that in a perfect world, you don't need to write it down. You understand? Like, I will look at a triangle like this, right here, and I will go to my calculator right away and go 41 divided by sine 65 to get B. Like, I don't need to write it down. I'm just doing it all on the calculator. As a matter of fact, I'm to the point where I could do all of this work in one shot on my calculator. I don't need to write anything down. I don't expect you to get there because I've been practicing a lot of trig. And as you well know, it's my favorite math. So I actually doubly pay attention to it because I actually enjoy doing it. I know, let's not make any comments about the weirdo at the front of the room that actually likes doing math for fun. You just keep your opinions to yourself. There's plenty of stuff you guys do for fun that I don't dig. I don't bug you about it. So you leave me alone. I like trig. Anyway, I'm a little defensive. I don't even know what I was saying. Oh, right. You need to be at that level, not quite like you can do it all in one shot on a calculator, but I want you so comfortable with sine, cosine, tan that when we get to this stuff, you're just like, oh yeah, I got it. Nailed, no problem. Because this stuff is really based on a firm understanding of SOHCAHTOA. Okay? Everybody good? Go. You can work with each other. You can move around. I don't care. Yep. So you are doing 95 and 101 right now.
Can I go to the washroom?
Yep.